So let's start by doing this activity. If you're watching the video, you can pause and then come back. Also, don't forget to do the student survey. Go into the course content and find the survey and complete that if you haven't already. Okay, we're going to start class. We have a Nearpod activity. I'll send this link out to you in an email. It will also be on our class homepage and the announcements. We'll give you the link that you can click on and complete this vocabulary assignment. Also, don't forget in the start, we have a vocabulary study set that you should review prior to coming to class so that you're familiar with the vocabulary that we'll be using during the lesson. In the announcements, you will see day by day what you should be doing for the course. Ideally, you should be getting into the course 30 to 60 minutes daily for review, practice, and keeping up with your notes. The more you can practice, especially if it's a new concept, the more comfortable you'll be when you get to the quiz or the test at the end of the unit. So this week on Monday, you should get into the course. Go ahead and complete the start, the vocab assignment. Read the material for 1.01. 1.01 is an introduction, so there's not a lot to do there. Just read it. And then start reading 1.02, taking notes and completing the practice. Review the vocabulary as often as you can in Quizlet. It'll be covering arithmetic and geometric sequences. So if your last name starts with A through M, you'll attend class on Tuesday at 9 o'clock. We have class from 9 to 9:45. We also have on Tuesday due the Desmos Math Lab Picture Perfect. That's due at 4 p.m. Continue reading the material in Unit 1.02. Go back and practice. Continue taking notes. Practice, practice, practice. On Wednesday, our whole group meets. If your last name starts N through Z, then you'll be meeting on Wednesday at 9 a.m. Continue reading the material for 1.02. Complete all the practice and take notes. On Thursday, we have a Nearpod assignment over arithmetic sequences due at 4 p.m. We also have quiz 1.02 due at 11:59 p.m. Finalize your notes for units 1.01 and 1.02 because you can turn your notes in at the end of a unit for extra credit up to 2 weeks after that test is due. Also keep in mind that we have a mid-semester lock date in mid-March. I think it's somewhere around the 19th, and we want to keep up with our assignments and don't let that catch us off guard. The target for today is to apply skills to evaluate sequences and series, including arithmetic and geometric sequences and infinite series with sigma notation. Some of this may be familiar to you, but I think that the sigma notation may be new. So again, the more that you can get in, look at that, write it down and practice, the better you'll be when we get to the assessments. So that when we go over this in today's lesson, you can build on the skills to understand how they apply to infinite series with sigma notation to solve real-world problems. So essentially, we're going to be covering 1.01 and 1.02 this week. And you'll know that you have it when you can complete the exit ticket and pass quiz 1.02. Now, what is discrete mathematics? That's this unit. It's the branch of math that deals with countable sets. Values are distinct and separate, and they do not vary. The set of objects can be finite or they can be infinite. And we'll be relating this to what we covered in the first semester when we were talking about vertical asymptotes and graphing equations. So some topics in discrete mathematics are things like theoretical computer science, information and coding theory, logic, set theory and combinatorics, probability, abstract algebra, calculus of finite differences, geometry, topology, game theory, and social choice theory. I recently had a former student who I probably had them about 10 to 12 years ago, and they were in a class where we competed or we entered a contest to create a website. We did a little programming, and they competed with other high school students nationwide, and they actually won first place. Now, it was scary for them because it was something new, but they were excited about the possibilities. They won first place, and the prize was actually computer games and an Xbox. So don't be afraid to try, even if it's something new, because you never know what you can learn. So we're going to take a moment to watch a video to introduce arithmetic sequences. Pay attention, and then we'll come back and we'll put that into practice.
Hi, let's learn about arithmetic sequences. An arithmetic sequence is made by adding the same value each time. This sequence starts at 1. Add 3 to get 4. Add 3 again to 7, and then to 10, and so on. The value added each time is the common difference. Let's make a coat hook board. The first hook is at 70. The common difference is 120. The next hook is at 190. Then 310. Then 430. The sequence goes forever, but we've run out of wood. Now for the hooks. Nice job. The common difference can be negative. This sequence starts at 14. Minus 4 is 10. Minus 4 is 6. Minus 4 is 2. And so on.
All right, in the chat box, go ahead and take your pencil and paper out. And we want to type in the answer as soon as you think you have it. What is the next number in the above pattern? So what we want to first do is we want to take any two consecutive numbers. So I'll just take the first two. I'll take 3 and 10. And I'll take that second number and I'll subtract the previous number from it. So 10 minus 3 is 7. So the difference is 7. So we're going to identify that as D. So D is equal to 7. Now take that difference and add it to each term to see if this is a true arithmetic sequence. So in other words, is 10 plus 7 equal to 17? Is 17 plus 7 equal to 24? Is 24 plus 7 equal to 31? And is 31 plus 7 equal to 38? So the answer is yes. So it is an arithmetic sequence. And so to get the next number, we would add 7 to 38 to get 45. Take a moment to look at that before we go on and try the next question. All right, try this one on your own. What is the next number in the above pattern? So again, take any two consecutive numbers. It can be these two in the middle. Take that second number, subtract the previous number to get your difference, and then simply add that difference to the last term to get the following term. All right, so the difference here, we're going to take 62 minus 71, and that difference is negative 9. So we're going to add negative 9 to 44. It's essentially the same as subtracting 9 from 44. So 44 minus 9 is 35. So your answer is 35. Let's try another one. Consider this arithmetic sequence. What is the common difference? So remember what I told you about finding any two consecutive terms. Just pick two and subtract the first from the second term. Take a minute or pause the video, and then we'll come back and we'll give you the answer. All right, so I'm going to just choose the first two. So I'll take the second one, negative 88, and we'll subtract 100, or subtract negative 100. It's important that you don't forget that negative. So when you subtract a negative, it's like adding a positive. So this is essentially 100 plus negative 88, or 100 minus 88 gives us positive 12. It's always okay, especially in class, if something's new or you get a little bit behind or haven't had enough practice, to say, I don't know, I'm still thinking. We only have 45 minutes in class, and sometimes new concepts seem to go a lot quicker, but it's okay to say you don't know or need more practice. Don't forget to join our Quizlet class for access to vocabulary and formulas for Unit 1. Now, the instructions to join are in our course announcements. So again, get into the course daily. Don't just go off of your plan or overdues, but get into the course and read the announcements. Any updates will be put in the announcements. Okay, what I'd like for you to do now is to copy down this formula for arithmetic sequences. Okay, we're going to start with A sub n. So for what A sub n is, for example, if we're looking for the 10th term, then A sub n is saying, I want to look for term 10. So n would be 10. A sub 1 is always going to be our first term, and D is going to be our common difference. We already had an example to show you how to take two consecutive numbers and subtract the first from the second to get the common difference. All right, let's put this formula into play in an example that we have here. So we're going to start with this sequence, and we're going to take any two consecutive terms. This time I'll take the last two, because it doesn't matter which two that you take. So 23 from 28 is 5. So we've identified D. So write that down. And we know the first term, A sub 1, is 3. Oops, kind of went squiggly on me. So A sub 1 is 3. All right, now let's plug that in, but we don't know what we're looking for yet. So I have to tell you, if I'm looking for the 10th term, then n would be 10. To find the 10th term, I'm going to plug in 10 everywhere I have an n, so 10 goes here. And this is going to be A sub 10 right here, so the 10th term. The first term we know, that's going to be 3. So 3 plus 10 minus 1. 10 minus 1 is 9 times D. Now we had to calculate the difference, and that's 5. So 9 times 5 is 45, plus 3 is 48. So the 10th term would be 48. That would work for any term that you're looking for. Now let's put that into practice, and you try one. We want to know the 100th term. So let's identify what n is. N is equal to 100. And we can determine what D is equal to. That's the difference between any two terms. So take any of these two terms. I think we've already done this in a previous example. Negative 88 minus 100 is going to be 12, so the difference is 12. And then we'll plug that into this formula. We want the 100th term. So A sub 100, another way of writing the 100th term, is equal to the first term, negative 100, plus n minus 1. 100 minus 1 is 99, times 12. All right, so the 100th term, let's go ahead and simplify the right-hand side. First, let's multiply 99 times 12. That's 1,188 plus negative 100. So we're going to subtract 100 from the 1,188 and get 1,088. So the answer is C. All right, suppose that we have the following sequence. We want to know the 202nd term. Now, this is where the formula is going to really become clear how important it is, because it would take us too long and would be too tedious, too many places to make mistakes if we're writing out 202 terms. So that formula is going to be very important. All right, so the formula says A sub n. Well, let's first identify what n is. N is equal to 202. And the difference, D, take any two terms, subtract any two consecutive terms. So we'll just take 28 minus 23. So the difference is 5. So we'll plug that into the formula. We're finding A sub 202, so the 202nd term, is equal to the first term, that's 3, plus n minus 1. So 202 minus 1 is 201 times 5. 201 times 5 is 1,005. Add 3 to that, and your answer is C, 1,008. Let's look at another example. We're going to use the same formula, but this time we're looking for the first term. We don't have the first term. We have the 15th term, and we have the difference. Okay, so A sub n, we have the 15th term. N is equal to 15. Okay, so A sub 15 is 50. I'm going to put that here. Is equal to, we're looking for the first term. That's going to be our variable, A sub 1, plus n, which is 15, minus 1 is 14, times the difference, and the difference is 3. Oh, I apologize. My pen just went crazy. All right, 14 times 3 is, let me get my calculator out. 14 times 3 is 42. So write this down here. We're going to subtract 42 from both sides. So we're left with 0 over here. We have 50 on the left. Subtract 42 from 50, and you'll have A sub 1. So 50 minus 42 is 8. So A sub 1, the first term, is equal to 8. Now we're going to move to geometric sequences, and we have a formula for the nth term. You'll find this in the course content and in the vocabulary in Quizlet. This is the formula, a sub n, so it looks similar to the arithmetic formula, is equal to the first term times a common ratio. This time it's not a difference, it's a ratio, something that we're going to be multiplying to each term instead of adding. Raised to the n minus 1 power. Okay, we're going to take a minute and watch a video to introduce geometric sequences. Then we'll come back and we'll practice. Write this formula down and be ready to put it into play.
Hi, let's learn about geometric sequences. A geometric sequence is made by multiplying by some value each time. Here we multiply by 3 each time. Start at 1, by 3 is 3, by 3 is 9, by 3 is 27, by 3 is 81, and so on. What we multiply by each time is called the common ratio. Here the common ratio is also 3, but it starts at 2. By 3 is 6, by 3 is 18, by 3 is 54, by 3 is 162, and so on. Here we start with 1. The common ratio is 2. By 2 is 4. By 2 is 8. By 2 is 16. By 2 is 32. By 2 is 64. By 2 is 128. By 2 is 256, and so on. The common ratio can be less than 1. Start at 10. By half is 5. By half again is 2.5. By half again is 1.25, and so on.
All right, now we're going to do the same thing that we did with arithmetic sequences. We're going to take any two terms. So I'll take 280 and negative 112. We'll take that second term and we'll divide it by the previous term. Now look at your answers to get an idea. We really want to keep it as a fraction, even an improper fraction, until we know what direction we're going in, if we need to convert that. So simplifying, keep it in fractional form, but I'm looking at my answers and even my series or my sequence, and I'm going to go ahead and divide negative 112 by 280, and I'm going to get negative 0.4. All right, so our common ratio is, go ahead and write that down, negative 0.4. Okay. So now let's put it into this formula. Well, no, we don't even need to do that because let me look at the question. We just need to know the common ratio, and we've already found it. Sorry, my pen is going crazy on me today. All right, now we want the 19th term in this sequence. We're doing the same thing, but now we're finding the term, not just a ratio. So let's identify what n is. That's 19. And then we'll find the common ratio. All right, so we already did that previously. It is, let's go back and I'll show you. It's negative 0.4 right here. So R is equal to negative 0.4. Okay. Let's put it into this formula. So A sub 19 is equal to the first term, 280, that's A sub 1, times the common ratio, negative 0.4, raised to the n minus 1. Now remember, n is 19, subtract 1, that's raised to the 18th power. Okay, now I'm going to show you how to put that into Desmos. If you have a TI-84 calculator, if you're using a personal calculator that you have, that's fine. All right, so, but for this course, we're just going to use Desmos. Let me go ahead and clear all that out. Okay, so we're going to put 280 times negative 0.4 raised to the 18th power. Now let's look at our answer for a minute because our answer choices did not look like this. We're going to convert this scientific notation. We're going to take that decimal point. We're going to move it 5 places to the left. So on your paper, move it over 1, 2, 3, 4, 5. So that's going to give us a decimal place and then 4 zeros. And then we'll have 1, 9, 2, 4, 1, etc. So let's go back to our answer choices. And what we have to choose from gives us this answer here, 0.00002. It's always okay to say, I don't know, I'm still thinking. Especially if we're going fast. This class tends to go fast. We have 45 minutes and a lot to cover. So it's okay to say you don't know. But that just means you should be telling yourself that we need more practice. And make sure that you get into the course and you practice daily, ask questions, come in for help. I'm available every day, either office hours or help lab. It's okay to let me try to find my pointer again. It's okay to just drop into help lab without signing up. But I'm going to give the attention to those who've signed up first, because sometimes people sign up and they don't show up, but you can always come in and just observe and get help that way. I don't want those slots to be not used. Also, if those times that I have in my schedule aren't convenient for you, reach out, let me know when you're available. We can always schedule one-to-one. All right, we want to write a sequence that has 2 geometric means between 32 and 108. So that means we have an average between these numbers, either by adding an arithmetic sequence or a geometric sequence by multiplying a common ratio. But that means we have 2 terms in between that we're missing. We know the first term, so we can go ahead and write that down here. And then we can see that we have 4 terms total. So the 4th term is 108. Okay, now what we need to do is we need to figure out what kind of sequence this is and fill in those terms. So take a minute to look at that. And, oh, it is a geometric sequence. I was thinking for a minute, how are we going to determine that? But it tells us it's a geometric sequence. So we need a common ratio. We're going to use this formula that we introduced previously. Trying to find my pen again. Disappears. All right, here we go. The formula is A sub n is equal to A sub 1 times R to the n minus 1. That's an R here. All right, now we know the 4th term, so we can go ahead and write this as A sub 4, or in other words, the last term of that sequence. And we know the first term, 32. We don't know what R is. We're trying to find that. Okay, we do know what N is. N is the number of terms we have, 1, 2, 3, 4. We also can get it from here. So 4 minus 1 is 3. Divide both sides by 32. And a sub 4, let me go ahead and put 108 here. Divide that by 32. And r to the third power is equal to 108 over 32. Now before we go any further, let's go ahead and reduce this, leave it improper, and I can divide by 2, and I'll find that I can divide by 2 again. Or in other words, just divide both of those terms by a common factor of 4. So 108 divided by 4 is 27, and 32 divided by 4 is 8. All right, now that we've reduced that, we're going to take the cube root of both sides, not the square root, the cube root. When you take the cube root of a term that's squared, that radical is going to drop, and you'll get r, which is what we're looking for, is equal to, now take the cube of each of these separate if you can, and 27 is a perfect cube. The cube root of 27 is 3, and 8 is also a perfect cube. The cube root of 8 is 2. So r is equal to 3 over 2, or 1.5. So to get, if you're looking for those second and third terms, you multiply 32 over 1 times 3 over 2. Simplify. Let me get my calculator out. It goes a lot faster that way. All right, 32 times 3 and then divided by 2 is 48. And then 48, put that over 1, and then times 3 over 2. Okay, let me go ahead and get my calculator out. 48 times 3 and then divided by 2 is 72. All right, let's practice using the formula to find the sum of the terms of a geometric sequence. Follow along. Stop the recording if you need to. Ask questions if you're in live class. This formula is saying that the sum of n terms is equal to this expression here. So first of all, we need to find a common ratio. We need r, we need n, and we need that first term. It's easy to identify that first term. That's 32. So a sub 1 is 32. The common ratio, take any two consecutive terms. So I'm going to take the first two. And in those two terms, take the second term and divide it by the previous term. So that's going to be negative 8 over 32, which is also the same thing as negative 1/4. And it is not a repeating decimal, so you can also write it as negative 0.25. All right, so we have our r written two ways. Right now, we have the first term. Let me see what else we need. We need n. So don't be fooled. Because we only see 4 terms, n is actually 6. Because we're looking to sum up the first 6 terms. Even though we don't have them written out, we don't need them with this formula. All right, so we have n, we have r, and we have the first term. So let's plug in a sub 1 into the formula. So we've got 32 times 1 minus r, and I'll just write it so that you can see it as negative 1/4. And we're going to raise that to the 6th power. Okay. And then divide that by 1 minus negative 1/4. All right, now I'm going to show you how to do this in Desmos, but I'm going to use negative 0.25. It's just easier for me to enter it into the calculator that way. Okay, so we're going to move over there and put it into the calculator. I'll demonstrate that in a minute. But when we put that in, we're going to get the sum of the first 6 terms is 819 divided by 32. And it's just easier for me. I'm looking at it because I want to make sure that I don't have any mistakes here, write everything down. It's easier to put it into a calculator. So use your scientific calculator. Let me pull Desmos up here. All right, so we had 32. And we're going to multiply that times 1 minus, let me put this in parentheses, minus negative 1/4. This is the way that I had it written. You can use decimals as well. Back that up. And we're going to raise that 1/4 to the 6th power. Okay, now we're going to divide all of this by 1 minus r. And again, you can write this as a decimal. You'll get the exact value, negative 0.25. Then I'm going to write it the way that we did it in our example. Minus 1/4, minus negative 1/4. All right, now let's see if that gives us a value over here that we can put down as our answer. All right, this is 25.59375. Look at your answers on the computer graded assignments and see if it needs to be in decimal form. You can calculate all of this out yourself. You can grind it out and get a fraction answer, which you'll get 819 over 32. If it's in decimal form, look at how the question wants you to answer it. So sometimes you have to interpret this answer. Right now we have 25 point, let's round that off to 25.6. Now we're going to move into sigma notation. So first we're going to look at what that Greek letter sigma represents. It represents a sum of a series. It's a summation symbol, the symbol right here. Now you may be thinking that it's inconvenient to write out each series in expanded form because it can get kind of long. You can have up to, an infinite number of terms. Actually, we have to stop somewhere. But if we had 100 terms to write out, that would get very cumbersome. So we're using the Greek letter sigma. Sigma stands for, similar to our S, stands for summation. Okay, sum of a series. Okay, so what that means is we start with an index. A lot of times you'll see this as an I, but it can be any variable. And it'll tell you where we're going to start on the bottom and where we're going to stop on the top. So we're going to start with the first term. We're going to go up to 6 terms. So that means that we're going to have an expression here. In this case, we just have 1, 2, 3, 4, 5, and 6. And then now we're going to add those together. So this would be 6 plus 4 is 10, plus 5 is 15, 16, 17, 18, 19, 20, 21. All right, now let's see if we can take these terms and write it in sigma notation. All right, A sub n is going to be, whatever we put right here is going to be our rule. I, or whatever variable we use here, is our increment. D is our difference if we have a rule. And n is the number of terms. So how many terms do we have? 1, 2, 3, 4, and 5. So we're going to start with one term, and we're going to go up to the 5th term. And then our rule is going to be written right here. N plus D times I. So we're going to take whatever numbers we start with, and we're going to add a number times whatever I is. Okay. Now we're adding the sum of the series represented by this notation. Okay, so let's start off and let's break that apart. We're going to start with the 3rd term, and we're going to go up to the 7th term. So how many terms will we have? Okay, 3rd term, 4th term, 5th term, 6th term, and 7th term. Okay, here's our rule. So we're going to plug that 3 in here. We're going to multiply it by 2. 3 times 2 is 6, plus 5 is 11. So that's what goes here. Okay, now we're going to take that 4 and we're going to plug it in here. 4 times 2 is 8, 9, 10, 11, 12, 13. Okay, for the next term, we're going to take 5. We're going to put it in here. 5 times 2 is 10, plus 5 is 15. We're going to continue with the 6. 6 times 2 is 12, plus 5 is 17. And then lastly, 7 times 2 is 14, plus 5 is 19. And then we'll sum all of those up. 19 plus 17 plus 15 plus 13 plus 11 is 75. But let me show you an example of how to work these types of problems. So you can rewrite the limit as n approaches infinity. Again, let me find my pen so I can write. Okay, the limit as n approaches infinity of this expression. So just take a minute to look at that. Now we know as this number gets bigger and bigger and bigger in the numerator, our value gets larger. But we also have an n in the denominator. The denominator makes, as it gets bigger and bigger and bigger, makes this number get smaller. But we have one in the numerator and denominator. This minus 3, we can kind of toss it out because it's going to be very insignificant as this number gets larger. So we're just going to simplify 6n over n. So the n cancels and we're left with 6. So as n gets larger and larger and larger, our value is going to approach. Don't know why my mouse goes crazy, but never actually hits 6 or gets to 6. Let's try another one. Your turn. So pause for a minute See if you can figure this out on your own, and then turn the video back on and see if we got the right answer. See if we agree. All right, so we have an infinite series represented by this notation. So as n starts at 1 and approaches infinity, what's going to happen here? So again, we can toss this part out. It's going to be very insignificant, and then simplify. So this cancels. So we have 3 over 15, which reduces to 1/5. If you write 1/5 as a decimal, you get 0.2. So this is what happens to this series. Remember, we're adding terms, but we're not stopping at a number. We're going to infinity. So what is it going to approach? It's going to get very close to 1/5 or 0.2. All right, so we have a Padlet. I'm going to put that in the chat. I will also put that in our announcements. So you'll click on that link and you will complete this activity. How did this lesson relate or connect to the real world, to our community, to our objective for today? So take a few minutes to go to that Padlet and just reflect on our lesson. All right, the next steps, put in your planner a minimum of 30 to 60 minutes daily for pre-calculus trig. Finish any course materials for sections 1.01 and 1.02. We're going to finish that up this week. Take notes and complete the practice material for 1.02. Complete assignments. If you don't do as well as you'd like, review the material in the ICANN and in the live class video, Quizlet, notes, etc. Attend office hours, help lab, or one-to-one. Give focused attention to the course material. That means get into the course, not just complete assignments and look at due dates. Take neat handwritten notes. Your success depends on being engaged. All right, our exit ticket, we're going to go to nearpod.com and put in the code CHLPX. I'll stay here. Or you can email me if you have any questions about this, but complete the Nearpod assignment.